Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Arif and I welcome you all in today's session. To access the notebook for today's session, you can access course page on my personal website arifpat.me. The other way is to download the uh, notebook file from course GitHub account arifpucat, and all the notebooks for this course are housed in this data science repository. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture 7.3 of the 7th module, overview of natural language processing, for the course titled Tools and Techniques for Data Science. Well, the title of today's session is Advanced Text Pre-Processing. My dear students, this is our third session, and I keep repeating that natural language processing encompasses all the tools and techniques that enable computers to understand and respond to human languages in written, verbal, and signed form. In the previous session, we started with the second phase of a generic NLP pipeline, and that was text pre-processing. For better understanding, we further divided this phase into three parts: text cleaning, basic pre-processing, and advanced pre-processing. Uh, we have studied in detail about the tasks that we perform in the text cleaning part, which are removal of unnecessary digits, spaces, new line characters, HTML tags, URLs, and punctuations. We also covered the tasks that we perform in basic pre-processing, which are case folding, expanding contractions, handling chat words and emojis, spelling corrections, tokenizations, n-grams, and stop words removal. My dear students, if you have not a clear understanding of these tasks, I strongly recommend that you should watch session 7.2 first and then fall back to this. Having said that, today we are going to do advanced pre-processing on our textual data before we do feature engineering on it and apply different vectorization techniques in our next session. Okay, let us move on to the agenda of today's session. So today we are going to do a lot of interesting NLP tasks like stemming, lemmatization, parts of speech tagging, named entity recognition, and coreference resolution. If you are interested to watch a specific topic out of these, you can straight away jump onto that by clicking the specific time link in the description box below. Well, my dear students, in order to perform different text pre-processing tasks, we will be using libraries like NLTK, spaCy, GenSim, WordCloud, and TextBlob. So let us install these libraries. I think I have installed them in our previous session as well. But anyways, those of you who are new must do this before proceeding any further. Okay. Well, my dear students, the word normalization is the task of putting words in a standard format by choosing a single normal form for words having multiple forms. It falls in three categories: case folding, stemming, and lemmatization. We have done case folding in our previous session where we converted our textual data into lowercase as the machine representation or ASCII code of lower and uppercase alphabets are different. And today we are going to talk about stemming and lemmatization, and they both are very much related as they both are used to convert word to its root form or base form. Well, my dear students, a token or a word is generally made up of two components: morpheme, which is the base form of a word, and prefixes or suffixes or maybe infixes. Consider these words: consultant, consultants, consulting, and consultative. The morpheme or base form of all these words is consult. My dear students, reducing such inflectional words to their base form, provided if the meaning remains unchanged, has a good effect on the performance of machine learning algorithms. And both stemming and lemmatization aims to reduce such words to their root or stem forms and are heavily used in information retrieval. Let us start with the stemming, which is a crude process uh, of chopping, the prefix, suffix, or infix blindly. My dear students, stemming algorithms use fixed rules such as cutting the suffix or prefix to derive the base or the root word. Its limitation is that it do so even if the stem itself is not a valid word of the language dictionary. For this, consider these two examples, studies and cries. Stemming has simply chopped off this es from studies and this es from cries. You can note that the resulting stem words are not dictionary words, and this is the limitation of stemming. Soon we will see lemmatization, which overcomes this limitation. Uh, Anyways, these are the four famous stemming algorithms: PorterStemmer, Snowball Stemmer, Lancaster Stemmer, and regex-based stemmer. My dear students, PorterStemmer is the most common of all, developed by Martin Porter in 1980. However, it can be used for English language only. If you are working on some other language, try Snowball Stemmer. Let me click this link to show you the famous paper of Martin Porter. Let me zoom it a bit. And let me scroll down and show you the 5 rules that this algorithm follow for reducing a word to its base form. Okay, so note these steps: step 1A, step 1B, and similarly we have step 1C, step 2, 3, and so on, with their mapping rules shown with each. For example, this step 1A, this says in case of suffix SSES and IES, simply chop off the ES from the end. Similarly, in case of SS and S, simply chop off a single S from the end. And the examples are shown over here. But dear students, I strongly recommend that you should make time and go through this paper. And let me fall back to the notebook. Okay, you can use spaCy library for stemming, which uses the best available algorithm, but right now I'm using NLTK, which has a support for Porter, Lancaster, Snowball, as well as the regex-based stemmer. I have imported all the 4 libraries, just in case you want to use them. But right now I will be using only the PorterStemmer. Over here I have created the PorterStemmer object and I've called the dir function on it to check out different methods that are available to us. Okay, for a crystal clear understanding, my dear students, about this PorterStemmer algorithm, you can run these functions. You see this step 1A, step 1B, step 1C, step 2, step 3, and so on. And let me play around a bit and use this step 1A for the time being. And of course, if you want to just perform all the 5 steps in one go, you can use this simple stem method. Anyway, So let's consider this. Okay, so before this, let me show you. Let me say that ps dot underscore step 1a. I just want to perform this step on the word on the same word which was shown over there, ponies, and let me run it. And you see, as per rule 1a, it has chopped off the uh, s from the end. IES from it. Let me say PONIES. So now it has chopped off the ES from the end, and this is what we have seen over here in the paper as well. From the IES, we have chopped off this ES from the end. Do try these examples. And let me change it to, let's suppose, another word, MOTORING, motoring. And step 1A has performed nothing on it. Let me fall back over here. Let me check out step 1B. And this is going to chop off the ing at the end and motoring to motor. Let me use step 1B over here. And you see it has chopped off the ing from the end. Well, my dear students, these rules, step 1A, 1B, 1C, 2, 3, 4, 5, so on, they are applied in sequence one after another. If you want to apply all the 5 set of rules in one go, you use the stem method of the PorterStemmer. Let me move ahead and show you a comprehensive example. Well, as usual, in the first 3 lines, I am just importing the PorterStemmer and word tokenized method from NLTK. This is our sample string having different inflectional words whose root words we want to find. Over here I am creating the PorterStemmer object. Then actually I am word tokenizing this string and passing each token or a word of this string to this stem method of PorterStemmer object. And finally I am printing the word along with its corresponding root word. Well, you can always use this list comprehension style, the Pythonic style, instead of the above loop. And of course, this will return a list of root words. But I think for understanding sake, this loop style is a bit better. So I've executed it. Great. Uh, you note that these first 4 words, wait, waiting, waited, and waits, all have been successfully reduced to the morpheme or stem wait. Similarly, the next 5 words, consult, consultant, consultants, consulting, and consultative, have been reduced to consult. However, my dear students, stemming doesn't always work. Note that these 3 words, university, universal, and universe, all have been wrongly reduced to non-dictionary word universe without an E at the end even. Similarly, the words studies, cries, cry, and bicycle also have been wrongly reduced. This word USA, United States of America, has been wrongly reduced to lowercase. And finally, the 2 words data and its singular datum are reduced to 2 different stem words. My dear students, these issues with stemming can be divided into 2 categories: overstemming and understemming. Overstemming occurs in 2 scenarios. When too much of the word is chopped off. For example, an example of overstemming is this studies, which has been chopped off. Overstemming also occurs when 2 words of different stems map to the same word. For example, uh, this university and universal are two different words but have been reduced to single root word universe without an E. Finally, understemming is the opposite of overstemming, in which two words of the same stem are mapped to different stems. For example, these two words, data and datum, should have been reduced to a single root word, but they are reduced wrongly to different stems. Okay, I think we are a bit clear about stemming now and its limitations as well. Let's move ahead and see how lemmatization can help us to overcome these limitations. My dear friends, stemming blindly chops off the suffix and prefix of a word and tries to bring a word to its base form without caring if the stem is a valid dictionary word or not. On the contrary, lemmatization uses the lexical dictionary WordNet to ensure that the reduced word, lemma in this case, is a valid dictionary word. This is the reason that it is time consuming as compared to stemming. We prefer stemming when the meaning of the word is not important for analysis. For example, in spam detection, we prefer stemming. And of course, it is recommended to use lemmatization when the meaning of the word is important for analysis. For example, while designing question answering systems. These are the differences summarized in the table form. Well, once again, we can use spaCy for lemmatization, but right now let me use NLTK's WordNetLemmatizer, which internally uses the NLTK's famous lexical dictionary called WordNet. And let us understand this piece of code. As usual, the first three lines, I am importing the WordNetLemmatizer and word tokenizer methods from NLTK. And this is our string having the words uh, on which PorterStemmer failed. Over here, I am creating an object of WordNetLemmatizer. And then I am just word tokenizing this string and passing each token or word of this string to the lemmatize method. Lemmatize method of our lemmatizer object. Let us execute this code. It has taken a bit of time. Note now the three words university, universal, and universe have been reduced to their appropriate lemmas this time. Similarly, the word studies, cries, cry, and bicycle has also been properly reduced to their stem words, which was not the case when we used PorterStemmer. The abbreviation USA has been identified as a noun, so it has not been reduced to lowercase. Hmm. Uh, well, over here, data and datum has been reduced to data and datum respectively. Uh, I think they should have been reduced to a single lemma. Well, if any one of my listeners has a logic for this, please give me a comment in the comment box below. And I move ahead. Excuse me. Okay. My dear friends, let us change gear and move to our next advanced text pre-processing technique, and that is part of speech tagging. And let me first brush up your knowledge about English parts of speech, which we all have studied and practiced in our secondary school education. Well, consider this sentence: Arif ate fruits. In this sentence, Arif is the person who is doing an act of eating fruits called noun. So this Arif is noun, a proper noun. This ate is the action, and this fruit is uh, also called a noun. And this ate is a verb. I think this makes sense. As you all know that noun is basically a person, place, thing or idea, while this verb is an action like eat over here. It can be drive, play, teach, run, and so on. In simple words, what I just want to convey is that every sentence is made up of different parts or words, and these parts are called parts of speech. Well, as per Wikipedia, there are roughly 10 parts of speech in English language. Now, consider this sentence. The quick brown fox name is Zorro, uh, and it high jumped over the lazy dog's back. Uh, my dear students, in this sentence, this fox and this dog are common nouns, while Zorro, uh, which is the name of the dog, is a proper noun. Rather, Zorro is the name of the brown fox, yes. And this word it is a pronoun, which is a word that is a replacement of the original noun. Other examples of pronouns can be he, she, I, me, and so on. Similarly, this quick, brown, and this lazy, they are adjectives. And we all know that an adjective describes a noun. The adjectives quick and brown describes uh, this fox, while this lazy describes the dog. Similarly, this word jumped is a verb, while this word high, which describes this verb, is also called adverb. My dear students, the way adjective describes a noun, the adverb describes a verb. Over here, this word and is a conjunction which is used to connect group of words. Other examples of conjunctions are but, or, neither, nor, and so on. This word the is a determiner which is indicating that the noun fox over here is referring to a definite element of a class. Well, my dear friends, then we have prepositions which are used to link a noun to another word. For example, in, on, at, they are all prepositions. Finally, in this example, we don't have the example of interjections, which are used to represent strong emotions like wow, hey, and alas. Well, my dear friends, now that we have a fair idea about different parts of speech of English language, let us now understand what do we mean by part of speech tagging. Well, it is a process of assigning a part of speech to each word in a text, and this is shown in this image. Arif is playing cricket. Where Arif is a proper noun, playing is a verb, and cricket is a noun. Well, these arrows shows the relationship between word and its neighbors. Uh, for example, who is playing and Arif is playing, great. And playing what? And of course, playing cricket. Moreover, we can divide different parts of speech uh, into two broad categories: closed class type and open class types. Well, these prepositions, pronouns, and determiners fall in the closed class category as they are more or less fixed in a language. On the contrary, uh, new nouns, new verbs, and adjectives as well as adverbs are continuously added in a language. Uh, for example, words like email, tweet, iPhone, uh, they do not exist in the English language maybe 20 years back. So, after having a fair idea about what is part of speech tagging, let's answer the next question, and that is why. Why do we need to tag the part of speech? Well, one of the application of part of speech tagging is named entity recognition, which we will do today. And others are co-reference resolution, word sense disambiguation, sentence parsing, and question answering systems. Now, another hard $100 question is how to do this parts of speech tagging. Uh, well, my dear students, since this is an introductory level module of NLP, so we will be using libraries like spaCy or NLTK, and I will avoid peeking behind the curtain. However, for interested students, let me tell you that part of speech tagging is just a kind of classification problem in which we label each word of over here, as shown over here, of our input text with its appropriate part of speech. So this is the classification problem. Uh, well, the part of speech tagging techniques can be subdivided into uh, three main categories as shown over here. And first is the rule-based part of speech tagging. An example is eBrill's tagger that goes through a dictionary or lexicon and finds out the set of tagging rules that best define the data. The second category is the stochastic part of speech tagging. An example is hidden Markov model that uses the emission and transition probabilities to generate the HMM. And of course, later either use the brute force or may employ the Viterbi algorithm for optimization. And of course, this third is the transformation based part of speech tagging. Anyways, avoiding the details, let's keep things simple. And we use a spaCy library this time to perform parts of speech tagging. Let me click this link and visit spaCy's linguistic features page. Well, this is a good source of information for part of speech tagging, lemmatization, named entities, uh, vectors, and similarity and other related stuff. Please make time to go through this page. And for the time being, let me fall back to our notebook. And let us do the part of speech tagging on this sentence. The quick brown fox name is Zorro and it high jumped over the lazy dog's back. The first thing we need to do is to import spaCy library. We need to import the pre-trained spaCy model for English language. So this is the pre-trained spaCy model for English language. This core is the model type that is used for lemmatizing, part of speech tagging, parsing, and named entity recognition. So let me load it. So this is done. Okay, now this NLP.pipe underscore names. My dear students, this variable NLP now is a pre-trained model of ours, and we pass or feed our textual data to it, and it returns some sort of output. The output is generated through a series of pipelines that perform some operations on the input text. So these are the different pipe names that comes with this model. And of course, we are interested in this Lemmatizer right now. My dear students, a pipe is an individual component of a pipeline. For example, tokenizer tokenizes the text into individual tokens. The part of speech mm, uh, tagger's job is to identify the parts of speech in the text, which is essential to understand how individual tokens are functioning in a sentence. Parser is used to generate a parse tree, and this NER pipe do the named entity recognition so that the machine should be able to make some structured decision about individual tokens. Okay, so this is the image that shows that you give the text to this NLP model, and it performs all these tasks and generate and gives you a doc object as output. Okay, let us create a sample text and pass it to the model instance named NLP, and this is what I am doing over here. This will create a spaCy doc object. Let me execute and check its type. So this is a doc object. Great. Uh, Let us print the spaCy doc object simply. It seems to be a string, but has, of course, a lot of attributes. To check out the attributes, let me use the dir function. So these all are the document level attributes, and of course we do have the token level attributes, and for that I am passing a specific token to the dir function, and these are the token level attributes right now in front of you. Okay, so let us check out the parts of speech tags that spaCy must have assigned to every token in this doc object. And for this, let me come up over here. Well, this is simple formatting task. This backslash octal 33 and then straight bracket is a control sequence introducer, and after this we have uh, specify a terminal control code in order to change the display attribute of a terminal. This 1M over here will print the text in bold, and later this M will reset to default. So actually what I'm doing is I'm just printing this token course parts of speech tag, fine grained tag and explanation in bold. Anyway, the point of our interest is this loop. Uh, Over here, well, I'm iterating over each token in the spaCy doc object and printing 4 pieces of information for each token. This token dot text attribute will display text of each token in a field of size 10. This is just formatting. This token dot pos underscore, this attribute of the token of spaCy doc object will return the coarse grained part of speech assigned to that token or word. This token dot tag underscore attribute of the token of spaCy doc object will return the fine grained part of speech assigned to that token or word. Remember, without the underscore with POS and TAG, you will get an integer hash value of that token instead of the text. And finally, this spaCy.explain method is used to view the description of the coarse or fine-grained part of speech. And over here, I am passing it the fine-grained part of speech. Okay, I hope this code makes sense. Let me execute it. Great. My dear friends, see how spaCy has identified the coarse as well as the fine-grained part of speech tags to all the tokens in our text string. Note this row. The word jumped. Of course, its coarse part of speech tag is verb, and the fine-grained part of speech tag is VBD. And the explanation of the fine-grained part of speech, that is VBD, says that it is a verb in past tense. This table, my dear friends, shows the additional attributes associated with every token of spaCy object. You can use them. We have used dot text, we have used dot pos underscore and dot tag underscore. You can use the lemma is alpha. These are the methods, attributes, and of course this table shows spaCy list of possible coarse grained part of speech tags. For example, this ADJ stands for adjective and so on. And this second table shows spaCy's list of possible fine grained part of speech tag. You can visit these tables if you want to know what different abbreviations are used for tagging. Anyway, let us do some more examples of POS tagging and consider this sentence: I'm going to make dinner and what is the make of your laptop? In both these sentences, the word make has different meanings. And spaCy used machine learning algorithms to best predict the use of a token in a sentence. It is quite clear to us that in the first sentence, the word make shows an action. So this is a verb. I am going to make dinner. This is a verb. However, in the second sentence, the word make identifies the class of a thing, and that is your laptop. So it is a noun. Let me execute the code of these two cells and see if spaCy can associate appropriate part of speech tags to these two words. Well, yes, spaCy has correctly associated the part of speech tags as per the usage of the word make in the two sentences. Over here it has identified make as a verb, and over here it has identified make as a noun. And remember, I have just checked out just this, the part of speech tag of this make, uh, because of this. Okay, let's see another example. Well, my dear friends, in these two code cells, the sentences have an ambiguous word, current. So, air currents carried the balloon for miles. Arif is swimming against the current. Strong currents pulled the swimmer out to sea. In all these three sentences, the word current identifies the class of a thing. So, it is a noun. Let us execute and see what part of speech tag spaCy assigns uh, to 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 words over here. So in sentence over here, this is noun. Okay, so if I comment this and I comment this and check out now, so this is also a noun. Great. So this is the coarse grained part of speech which says it is a noun, and this is the fine grained part of speech tag which says it is NNS, and its explanation says that it is a plural noun. Similarly, the sentence in the second code cell seems to be using the word current as adjective. The current version of this notebook is on cloud. I am satisfied with my current income. The current balance is rupees blah blah blah. So we are using the word current as adjective in all these three sentences, as it is describing a noun over here. The current version, the current income, and the current balance. Let me execute spaCy and see what part of speech tag spaCy assigned to the word current in this third sentence over here right now. So it is of course adjective. Let's see one more example. Well, consider this sentence: Arif reads NLP books. The word reads is of course a verb, but the S at the end tells that this is third person singular present. Let us execute and see what spaCy says. Well, yes, spaCy says the same thing. Now consider this second sentence: Arif read NLP books. Over here, the word read is used as past tense. Let us execute and see what spaCy says. Great. Okay, now consider this sentence: Arif has read many NLP books. The word read is a verb and is used in past participle tense. Let's execute and see what spaCy says. Great. And finally, consider this sentence which says Arif is reading the NLP book. The word reading is again a verb, but this time it is used in present participle tense. Let us execute and see what spaCy says. Great. So I think spaCy is really great in part of speech tagging. My dear students, if you have a big document and you want to know the count of different parts of speech in that document, you can use this count by method of the spaCy doc object. You see over here I am passing spaCy attrs.pos to the count by method, which will return me a dictionary. Uh, Let me execute this. Remember the doc object has been created on this string this time, and which says that I'm a runner running in a race because I love to run since I ran today. A lot of verbs there. Note the output is a dictionary, and the keys in the dictionary are the integer values of the given part of speech tag, and the values are the frequency. Let me show you this. Let me check out the token at the fourth index of the string, which is of course running. Let us view the coarse grained part of speech tag assigned to running by using the POS underscore attribute, and it is a verb of course. And let me show you that without underscore, it shows you the number, which is 100 over here. Now you can understand the output of this count by method in the dictionary. This 100 is the numeric code of the part of speech verb, and the corresponding value 4 shows that our input string has 4 verbs: runner, running, run, and ran. Great. Let me move ahead. Oh, well, my dear students, a picture is worth a thousand words. To graphically display the parts of speech tags in a document, you can import the spaCy module of spaCy library. Well, if you are working inside the Jupyter Notebook or a similar environment, you can use simply this uh, render method uh, of spaCy to show the visualization. And if you are working on a command terminal or using some code editor or some IDE, then you need to use this serve method of spaCy, which will run a server at port 5000 on your local machine, and you can view it on your browser. Let's see this in action. We just need to pass the uh, spaCy doc object to this render method of spaCy. Do see the help page for other arguments, and let me execute it. Great. You see the visual representation of the sentence with part of speech tagging. Great. Well, my dear students, you can of course customize the appearance by using the options argument to the render method. The customizing options are shown in this table over here. Let us see this in action. We need to create a dictionary object. Well, this compact value is true. That means use straight arrows instead of curved, which will save the space, of course. This distance of 200 specifies the distance between two adjacent tokens, and similarly you can set the foreground and background color as well as the font type, and you pass this dictionary object to the option argument of this render method. Let's execute. You see, it's great. So this was if you are inside a notebook, Jupyter Notebook or such like environment which is running behind inside a browser. But if you are not using a browser-based IDE, then you can use the serve method of spaCy. So this is the serve method of spaCy. Let me execute the code of this cell. And since we are running inside the Jupyter Notebook, so it has shown it over here as well. And in the bottom over here, you can see it has started a server on my local machine at port 5000. Let me click this link and it will open a new browser tab with the part of speech tag graph. Let me close this browser and fall back over here. You see it is still running. If you see over here, this static shows that the code is still running because the server is running. So we need to shut down the server and return to Jupyter Notebook. So for this, you need to interrupt the kernel by clicking the black square button in the toolbar or through the kernel menu, or maybe you can just press II twice, and I have done that. So we are back. Let me move ahead. Great. So we are done with part of speech tagging. I think that is enough of discussion. Let's move now to our next topic, and that is named entity recognition. Okay. My dear students, an entity is a common thing that belong to a noun family, and it can be a subject or an object. Consider this sentence: the president will meet the chairman of the company in the capital city. Over here, the words president, company, and the capital city are entities. Now consider this sentence: Trump will meet the chairman of Google in New York City. Over here, the word Trump, Google, and New York City are named entities. So, a named entity is a real world or conceptual object that can be represented by a proper noun. Some examples of mm, named entity categories are mentioned over here. These can be organization, person, location, address, date, time, money, and person. And these are some examples of these. So if you know what is a named entity, so let's move on to next question, and that is, what is named entity recognition? Okay, so my dear students, named entity recognition is actually a subtask of information extraction that seeks to locate and classify named entities from text. Consider this sample text. Arif has moved to Karachi, where he will be playing basketball on 25 December 2022. So the first step is to locate named entities. Uh, and I have successfully located and highlighted Arif, Karachi playing basketball and 25 December 2022 as named entities. The next step is to classify them into appropriate NER categories or types. So I have classified Arif as a person, Karachi as a GPE or geopolitical entity, playing as an event, basketball as a product, and 25 December 2022 as a date. So this is what NER is. And this table shows different categories of named entities along with their description and example. And of course, you can add more at your own as per the domain. My dear students, the next question is why NER? So there are different application areas where you cannot proceed without named entity recognition. And for example, these are Coreference Resolution, information extraction, search engines, recommendation systems, and question answering systems. So after answering the what and the why part, let me answer the natural third question, and that is how to do NER. The industry approach is to use libraries like spaCy, NLTK, or Stanford NLP NER. However, being researcher, you should you should design and build your own NER systems using either the dictionary-based approach by storing as many named entities in a list called gazetteer and later do a simple lookup. The second approach is rule-based approach where you manually create rules for NER. For example, a rule can be that if there is a word followed by INC dot and the first letter of the word is capital, then you classify or identify that word as an organization. My dear students, spaCy library provides a class called entity ruler, which you can explore at your own time for writing rules. And finally, the third approach is the machine learning based approach, where you can use the support vector machine, hidden Markov models, maximum entropy Markov models, and conditional random fields for the purpose. Let's keep things simple for the time being and let us explore how spaCy library can help us do the NER task. And let me click this link and go to spaCy 101 page. Well, my dear students, spaCy can recognize various types of named entities in a document by asking the model for prediction. Please make time and go through this page and let me fall back to our notebook and see the first example. As usual, the first thing we need to do is to import spaCy and load the small pre-trained model for English language. Once again, the genre is web over here. You can use news. The type is core, which is for general purpose pipeline with tagging, parsing, lemmatization, and named entity recognition. It can be DEP, DEP, for only tagging, parsing, and lemmatization. Let me execute it. And once again, let me show you the pipe names. As I've said earlier as well, this variable NLP now is our pre-trained model. Okay, so let me check the different NER tags that this model support. Let me execute this. So these are the different NER tags that this small English model support, and you can check out the attributes of these as well. Anyway, so we have date, time, organization, person, quantity, product, and many more categories of named entities. Okay. Let's consider this sample text. Arif works full-time at Punjab University since March 2005 and part-time in Twitter. Well, actually I'm not. I'm just saying it. So in order to do part of speech tagging for NER for this, I just need to pass this string to the model, which will return me the doc object. And over here I'm just iterating. We have already discussed this doc object has many document level as well as token level attributes. Here the document level attribute is ENTS, which is of our interest, which contains all the entities, and for each entity this loop is printing the text as well as the label underscore attribute. Let me execute it. Well, spaCy has recognized Punjab University as an organization and March 2005 as the date. However, it has failed to recognize Arif as a person and this Twitter as an organization. So Arif and Twitter are false negatives and they are named entities but not recognized as such. Let us see what we can do. Okay, let me change this Arif to, let's suppose, Dr. Arif and run the code again. And you see it has now recognized Arif as a person. So that means there is some rule which is triggered that says that after a salutation, If there is a word with first alphabet capital, then it is a person. Okay, great. Let me make the T of this Twitter as capital and run the code again. Great. You see, uh, by making the Twitter with the capital T, the model has identified the named entity, but is saying that this is a person. Okay. Uh, Let me write INC after Twitter, which is normal convention at USA for organizations. And let's execute the code now. Great. So now the spaCy has correctly located as well as correctly classified all the entities in this text of my interest. But for this we have to make changes to our text. The reason why uh, this has not worked perfectly is because they are dependent on the example data. Uh, this doc object is dependent on the training data on which the model is created. This NLP model is created. Or maybe on the rules that are written manually to locate and classify the entities. I hope this makes sense. Uh, this table shows the different annotations associated with each individual ENT object of the spaCy doc object. We have used this label underscore and text. You can use the other as well. Let's see now how we can add a named entity in our spaCy doc object. Once again, consider the same text. Arif has moved to Karachi where he will be playing basketball on 25 December 2022. Let's execute the code of this cell. The output shows that it has only located and classified the uh, date correctly. Okay, so even it has not uh, located Karachi as a city, but it has wrongly classified it as an organization. Moreover, it should have located and identified Arif as a person, this playing as an event, and this basketball as a product. Let us add these three entities in a doc object, and for this you need to understand the concept of uh, span in spaCy. Uh, so this is the doc object from 10 to 11, 10 inclusive and 11 not inclusive. This is the word basketball. And over here we call this a span. Let's check out the type. So this is a spaCy span. Now in order to add or modify these named entities in a doc object, first we need to import the spaCy uh, span class from spaCy.tokens. Then we need to create a span object for every named entity in our doc object using by passing it 4 arguments. The first argument is the doc object. The second and third argument are the indices of the span object. And the fourth argument is the NER tag that we want to assign to that span object. So 0, 1. So at 0, 1 we have this span Arif and I want to assign it the label person. 9, 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 10 is this basketball. And of course, I want to assign it a product. This 10, 11, 9, 10 is event. 9, 10 is this playing. And finally, this 4, 5, that is 0, 1, 2, 3, 4, 4, 5. 4 is inclusive and 5 is not inclusive, is this Karachi. And I have assigned it the label GPE. So, and finally, after creating these span objects, I am passing the list of these span objects to set underscore ENTS method of the spaCy doc object. Note S1, S2, S3, S4, I have passed the span objects as a list. And this default is equal to unmodified says that preserve the current state of the doc object. I hope this code makes sense. Let me execute it. So it has executed, and now let me execute the code of this cell as well, which is just going to print the named entities. And great, you see 1, 2, 3, 4, 5, all the 5 entities have been correctly located as well as identified. Arif is a person, Karachi is GPE, and this playing is an event, this basketball is a product, and of course this is a date. Great. Okay, let's do one more example, and this time consider this text containing lots of medical related terms. Dr. Khurram has diagnosed that the patient is suffering from pneumonia. Patient's left lung is inflamed and the air sacs in the right lung seems having filled with mucus. Patient is advised to have plenty of water and antibiotics. In case of chest pain, he should take painkillers. So let me create a doc object from this. Let me print the doc object and let me identify the entities and print them on screen. Okay. So spaCy has completely failed over here. My dear students, for this you have to build your own NER system or use some other pre-trained model that can recognize this uh, medical dictionary. So if you want to train your own model, you can use dictionary-based approach, rule-based approach, or maybe machine learning-based approach. So far, so good. Well, my dear students, the way we have used the render and serve methods of displacy module uh, to graphically display the parts of speech tags. We can do the same for named entities as well. Over here in this piece of code, in this cell, I'm creating the doc object from this sample string, and then I am passing that doc object to the render method of displacy. The point to note over here is that I am passing this argument to the render method, that is style is equal to ENT for named entities. The default value of style argument is DEP for parts of speech. And finally this third argument, Jupyter is equal to true. This means that we are running this code inside Jupyter. Let me execute this code. Great. Note that the model has identified this Nike as an entity and classified it as an organization. This U.S is classified as GPE, that is geopolitical entity, and so on. Great. Well, at times, my students, you just want to view only specific entities. In huge documents, you don't want to see all the entities, you want to see the specific entities. And for that, you can use the options argument to render method, which I have shown over here. And this is the same document. I just want to uh, render only the organization and date. Let me just execute it. So you see, uh, only the organization and date has been located and classified. Well, my students, you can check out displacy.serve method at your own. This is simple. We have done it in part of speech tagging. Let me move ahead. Okay, co-reference resolution. My dear students, the last topic that I want to touch upon before closing today's session is co-reference resolution, which is the process of identifying noun phrases that refer to the same entity. Well, consider this sentence. I voted for Imran Khan because he was most aligned with my values. In this sentence, this word Imran Khan is the antecedent, that is the first mention, while this he is anaphor, and that is the subsequent mentions. Uh, well, this output graph, visual representation of co-reference resolution, has been generated by the online service of Hugging Face, available at this link. You can do that at your own. And the next question is why co-reference resolution? My different co-reference resolution is used in a variety of NLP tasks like information extraction, information retrieval, text summarization, machine translation, and question answering systems. And finally, how? My dear students, the next and the final question, uh, how? Well, of course, it requires a pre-processing pipeline that consists of variety of NLP tasks like stemming, lemmatization, part of speech tagging, named entity recognition, and of course, finally, the entity linking or wikification, which is the process of textual mentions of named entities to their corresponding entities in a knowledge base. Uh, Interested students should download the Neural Coref library for Coreference Resolution that is also introduced by Hugging Face. You can download it from this link. Okay, I think that is enough for today's session. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.